I want to start with the process of the roll forming of shapes which have a discontinuous cross-section. And you can imagine that this is, I would say, the difficulty of roll forming in power, in a more extreme situation, because you have to imagine a flat strip which is pre-cut in the beginning. And let's have a look at this portion here. This small segment here will be stretched to this one, will be stretched to that one. And on the opposite side, we have areas which are going to be compressed at a huge extent. So we are reaching the formability limit of the material, and we have to clearly understand what's going on in the whole process to be able to get a proper product. So because in stamping, for example, you have the material is the sheet is just covered by the lower and by the upper die. There's no way for the material to escape. You have a big spring back later on, etc. But the material is covered by the tool. In roll forming, the material is between the different roll stands, so it has possibility to get its equilibrium, to find its way, which is then ending up in undesired warping, wrinkling, etc. So it's very important then to know in advance what will happen at what position, and when this and before this occurs, you have to fight it. You have to avoid it. This is the way we have been working, and the lower picture show you just a little principle on this kind of forming. So the roll tooling is not only moving, it's also rotating, and therefore we developed several components, mechanical components, which allow you to turn, to rotate, to move the tooling, etc. And coming to some examples, we have on the left side now a few examples of profiles which are variable in width. They are all in common, and the common similarity is there is a width variable, either conical or flexible on this side, plus on this side, or flexible in the width only on one side, or for example, if we come to roofing industry, also flexible on both sides of the width.